Good afternoon. Good afternoon, everyone, and thank you for joining us for this exciting webinar. My name is Christian Kotze, and I'm the product manager for Bequant at MiRO, and we are very proud to announce that we have joined forces with Bequant. For those who are not familiar with MiRO, founded in 2003, we have grown into being among South Africa's leading distributors of wireless, networking, VoIP, and IP video products. We believe in not only selling the best products to the ICT industry, but also to focus on the best solutions available, backed up by a strong pre- and after-sales services and support. We thank you for your time set available to join us for this webinar today and hope that you will enjoy it with us. Please use the chat function to send us questions. We will try to answer them at the end of the presentation. Without further ado, I'm going to hand over to Jose Lopez, the CEO at Bequant, that will be giving us some more technical details and features that Bequant offers.
Okay, thank you very much, Christian, and thanks to everybody for joining us. And let us try to show you what our product does.
Thank you.
Our product is a network optimization product. We can optimize your network. How do we optimize your network? We do it in three ways. First, we accelerate it. We increase the actual speed that your customers will experience, the customers in your network, with TCP optimization. Then, since this is a product that is inline, that through which all traffic goes through, we analyze the traffic as it comes, and with deep packet inspection, we can tell you what traffic is going through your network at any time. And then, since we can identify different applications going through your network, we can specify, we can set limitation, speed limitation to some of those applications at certain times for certain subscribers when it makes sense. So let's start with the acceleration. When we say we accelerate, what we do is we increase the speed experienced by your network users, which is not the same as the speed that your network allows them to have. For instance, if someone has a channel, a subscriber has the possibility to go because of all the connection path and the wireless channel to go at 10 megabits per second a certain time, but that subscriber is watching a Netflix video stream, and Netflix is sending at 5 megabits per second. 5 is what he thinks he has, and not 10. And what we do in those situations is to let Netflix or whichever application use more of the available bandwidth. Instead of sending at 5, we let it send at a speed closer to what the network actually allows. So, of course, the next question then is, why would Netflix or any application send at 5 megabits per second when it is possible to send at 10? And the answer is transport protocols. Among them, TCP. These are the protocols that, for instance, if we follow the example of Netflix, at the Netflix server in the Netflix data center, this is the piece of software of logic that decides at each point at what speed to send the video stream. If it sends it too fast, in our example, if it sent it at 20 megabits per second, there would be packet losses because there's only 10 megabits available. And if it sends at 5, then we leave capacity unused. So TCP, like other protocols, like all these protocols, they are very intelligent, and they start at a lower speed and then go ramp up and get to the optimal speed. However, when there are wireless networks in the path, and nowadays with Wi-Fi, there's always almost always some wireless in the path, or if there are packet losses, or if the data server is very far away, then TCP many times, ends up sending at a lower speed, because in this process of ramping up, at some point it will confuse the packet losses or the variability introduced by wireless networks with having reached the optimal speed, and then it will stop ramping up earlier than it should. And the result is that it will be sending at a lower speed, and the subscriber will not be enjoying all the speed that actually is available. So when the transport protocol is TCP, and that is with more happens with more than around 90% of all internet traffic and most applications, then we can help. And how can we help with our product? We can help by with our appliance. When you put it in the path, somehow we have to get our appliance, which is a software running on an off-the-shelf server, as we'll see, placed in your network so that all the traffic goes through us. Then whatever is TCP, we will optimize. What's not TCP, we'll just forward and also analyze and limit, as we'll see later. And what we will do to analyze is no magic. What we do is just is called a transparent TCP proxy, and this is a functionality that has been used for a very long time, for more than 20 years in all satellite networks. It's also used. It has been used for many years in most of the largest wireless carriers worldwide, like AT&T in the US or Vodafone in many countries where they have large networks. This is a functionality that's being used in large networks and in satellite networks, large wireless networks, for a long time. What we have done is to take this functionality and make it available for smaller networks. And so what does this transparent TCP proxy mean? What do we do? Let me show you with an example why this application can help any network, really. Let's imagine we have two servers here on the right, okay? And these two servers want to send 7 packets. This is just an example. So TCP would normally do this like, instead of, it will send 1, then 2, then 4, then 8, then 16. So it will be trying to probe the capacity of the path. And so it will ramp up and see how many it can send. Okay, and then the clients will send these acknowledgement packets when they get one round of packets, okay, and so we can send more. And here on the top, we will be doing this directly as it is normally done. And in the bottom, we'll do this placing one of our appliances in between. Like if this is a 5-second path, 2 and 3, this is just an example. And we'll count the packets as they arrive. So when the first round of packets, in this case with 1 packet, reaches us, we will be sending one of those acknowledgement packets back to the server as if we were the final client saying we got it okay. So the server, when it gets that acknowledgement packet, it will then send the second round already to us, which we will store in our system. And now when the real acknowledgement comes from the client, when it gets to us, we can already send this second round of packets. And with this, for instance, in this example, we've gained 4 seconds over the path at the top. And the same will happen with the third round. Now, another 4 seconds we get ahead. So if we have completed this 7 packet download in 17 seconds in this example, the top path will have taken 25, 4 and 4, 8 seconds more. Of course, this is just an example with large numbers, but this is the basic thing. The key of our product is this buffer that we are building in our system, so that for the client, once after the first round, it feels that the data is coming from your network, from your data center, instead of coming from maybe this Netflix data center, maybe in another country far away. And so it will, because when it sends these acknowledgement packets, it gets the data, the further rounds earlier. And being closer as it will feel that data is now closer, it is already in your network, it's just faster. So we are accelerating because we are making the data contents appear closer to your subscribers. And this is not only in normal situations, especially if there were any packet losses. TCP has no problem with packet losses. It just retransmits whatever is missing in those acknowledgement packets. So there is information of what packets are missing, and then they are retransmitted. But of course, we gain a lot if we can retransmit it out of the buffer that we have built in your network, instead of having to get those retransmissions from far away. So this is the second mechanism why you get acceleration in a transparent TCP proxy. And then there is a third one, which is a very important one also, and it is that when we do send from this buffer the data to your customers, we do that with our own TCP stack, which is just an adaptation of the standard TCP, but with algorithms that we have patented that are specially designed for wireless or for lossy networks, so that basically when we will not be confused by the packet losses that may happen with wireless networks, and we will therefore get to the optimal speed that there actually is in this path with much higher probability than regular TCP. So how do we prove all this? Well, this is how we prove this with real measurements. And let me explain this slide because it has a lot of data in it. But our system is already running in over 70 networks worldwide. Many kinds of networks, from wireless ISPs to fiber-based ISPs to cable to wireless mobile carriers. So these are 12 of those customers. And in every customer, we always leave 1% of all TCP connections at random without any optimization. And we do that so that we still measure those and we have a reference, something to compare against. And so a way to see how much we are really accelerating, because we compare the speed of all those downloads that are not being optimized, that are few, but we have plenty of them because there are many downloads happening all the time. And we compare them with all the rest of the traffic that we are optimizing. We measure those speeds of each of those downloads, and then here we compare them. And for instance, here in gray, we have the speeds we are measuring for the not optimized traffic, and then in red, the speeds, the average speeds we're measuring for optimized traffic. And this is data for a week or so in all those networks. So it's millions of downloads there. And we saw that it is something that we can compare more easily. We have just concentrated on the Netflix downloads because it's nothing. I mean, I'm talking all the time about Netflix, but it's just because it's one of the biggest volume producers in networks in all around the world. But for us, any TCP-based application would be the same. So in this case, if we look at, for instance, the fourth wireless ISP, what this means is that without us, Netflix, on average, it was sending at 1.04 megabits per second. Okay, on average, it could be much higher and sometimes lower at times, but this is an average for a week for all the customers that were not being optimized. And then with us, it was going at 2.5 megabits per second. So this network could actually support going at 2.5 megabits per second because when we sent at that speed, it did go through. So, but for some reason, well, the reasons that I told you before, Netflix was just not using all that capacity. And so it was sending at 1 megabit per second. So with us, in general, all these subscribers in this network are now getting the network is exactly the same, it just has our appliance in it. And they are now getting Netflix at a substantially higher speed. How much higher in each network, we don't know until we try it out. But then that's what we will be telling you. Try it out because we are offering a free trial period for you if you would like to see how much we can accelerate in your network, because every network, as you can see here, we accelerate, but different amounts, sometimes more, sometimes less. Sometimes you start with a higher number, sometimes you start with a lower, like for instance in fiber networks where we start with a much higher number. and then we end up also with a higher number. So we have to see exactly in each network, because there are so many things in speed that matter. So this is all that I'll tell you for now about acceleration and TCP optimization, how we improve the speed in your network. Now, the other function that we can perform is to analyze what is going through your network. For instance, here, this is an example of what we can show you. This is a network. We have a fairly large one, wireless ISP in Italy. It has a peak throughput of 14 gigabits per second. This is 3 days of traffic. This is the typical, this night, a day. This is a typical thing you see from a network. Here we break down that traffic by application, so that at any time, for instance, here at 10 p.m. at night, this was the breakdown. It was 11.6% YouTube, 8.3% Netflix, then Facebook. And so here with this, you can see what is going through your network at each time. Of course, we can give this all aggregated for that period. And then the other thing that we can also look and see is about which subscribers, for instance, how they are using your network. For instance, here we can see all the traffic for all your subscribers, and we can tell you about the 30 subscribers with more active subscribers. And for instance, in this case, these are those 30 more active subscribers. And sometimes you can see interesting things, like for instance, this subscriber looks like when it connects to the network, it starts using it at the maximum speed, because in this network they had a 6 megabits per second plan. So maybe this subscriber is doing something strange, some virus, or maybe it's I don't know. We give you this information. Then you can do things, and you can see what your subscribers do and how they behave. And also you can see if they have had some problems or not by looking here at seeing how much actual traffic, speed they were getting at different times. So this is about giving you information, knowledge about your network. And then the third thing that we can do is about, since we can identify different applications, even when they are encrypted in your network, then we can use that to set a speed limitation to some of those applications. And why would you want to do that? For instance, of course, you can always limit the speed of any applications, for instance, with us, but there are some applications that make more sense than others to limit. Because, for instance, if you have a video streaming, is an interesting application. It is the one that is the most used. If you look at the breakdown in this network, YouTube, Netflix, Instagram, which is mostly the video. These are the usually 50% or more of the volume in any network. So that's one thing. And then the other thing is that if you do limit the speed of these applications, then they all use a technology called ABR, adaptive bitrate, nowadays. And this means that they will see if they see that the speed of the network is lower, they send at a lower resolution. And if they see it is higher, they send at a higher resolution. And this, of course, it means that the volume transmitted will be higher. For instance, this is with Instagram TV, which is just one application that is now quite popular, and they use this APR. If you send, this is a 2-minute video that of some guy doing surfing, and without any limitation, this took 24.8 megabytes. If you limit that to 1 megabits per second, then that same video is 4 megabytes only, so 6 times less. Of course, the resolution is not so good. But at 2 megabits per second, for instance, the resolution then is quite okay if you're using any portable device like a phone, handset, something like that, and not so much maybe for a big TV. But then if you use 3 or 4 megabits per second, then it's still, for instance, a fairly good resolution for a TV set. So the thing is that if you do some limitation, at some point you can still have a reasonable quality. And of course, so we did this experiment in one of our customers. For a period of 4 days, we limited only the video streaming, the rest was not limited, to 4 megabits per second per user. Any video streaming would count for up to those 4 megabits per second, whatever it was. And we did this on even hours, and then in odd hours we didn't do any limitation. And we have here the results. In red is the optimized the hours when we were limiting. In gray, it's when we were not limiting. And you can see this is 4 days of traffic in that operator. And you can see how the traffic went up, of course, as you would expect, especially during peak hours when there was no limitation. Okay, so around 15%. But the good thing is that we can do this so that only when there is you maybe are reaching a congestion, so that you can do this maybe when your network is at 80% of the traffic, maybe, because probably at night, right, like in these troughs, you don't care, and so you can live. You don't have any need for limiting. However, maybe during more saturated times, there is, if you do this kind of limitation. In this case, we got no complaints because at 4 megabits per second, you can even have 2 Netflix sessions at the same time, and the quality will be good. And so without limiting that, in fact, the quality overall in the network was better, because some people that maybe would have at that time would be going at 4K resolution. Now they are not, but they are leaving that extra capacity so that all the rest, the ones that may have more limited, more limited connection, they can go better. And not only that, we also observed, here is the graph on the right, on the bottom, we were measuring at the same time the average latency, and we saw that it went down by around 5 milliseconds. And why would this happen? And the reason is that all these video streaming adaptive bitrate, basically they take all the bandwidth that they can get, and when they do that, they fill up buffers. So if you limit them, then this buffer fill up doesn't happen so often, and so you reduce the average latency. So applications that rely a lot on latency, like gaming or voice over IP, would go better. So we have here a case in which limiting the speed of certain applications can actually improve. You can do this not so much maybe for bandwidth saving, but for actually improving the overall quality of your network. And you can do this in a simple way through our system, because you can select which applications you want to limit. We have a number of signatures that we keep updating. You can limit this to certain subscribers by IP address or VLAN tag. And then you can set the threshold. Only do this when the whole network is running above, for instance, 800 megabits per second, if you have a 1 gigabit per second network. And here, of course, is in this case the 4 megabit per second limit. So, of course, there are already other systems that can do these limitations per application. But we have some advantages. For instance, we are doing this at the same time we do the TCP optimization. So we are still, for instance, if we have this 4 megabits per second limitation, we are still helping those connections going at maybe at 1 megabits per second to get up to 2 megabits per second. Of course, we're no longer helping those at 3.5 megabits per second. We will only get them up to 4 megabits per second because they are limited. But we're still helping the ones that are more in trouble. And not only that, because we are doing this with TCP, on the TCP part, we can do all this limitation without dropping any packets. Because in those acknowledgement packets that I was talking about at the beginning, that the client sends all the time when it gets things all right, you can also set the window, how many more packets you can accept. And with that, you can actually set the speed very precisely at which the server will send to you. And so you can actually set the speed of that you will get the data, and not have to do, as you have most of QoS systems have to do, which they keep a buffer, and if the stream goes faster, then they have to drop packets. In fact, we still have to do that ourselves. We do that for the UDP part of traffic, because there we don't have this TCP mechanism. But for TCP, we can do all this limitation without dropping packets, and all this means a much better quality when doing this QoS. So we are all focusing this QoS to really actually to get you the best quality, while and not so much the save, and not only the savings in bandwidth. Okay, so far I've talked about the three things that we do today. We started, in fact, in our history with TCP optimization. We've added this DPI, the packet inspection, and this bandwidth management more recently this year. And now we're working on more things that we can do to help you. And all these things we are bringing you with, if you have the support, for no additional cost so far. So, for instance, now we are now detecting denial of service attacks. Some volumetric and SYN flood attacks, so that we can detect them, inform you, and the next step will, of course, be try to then see the culprit, and then in fact try to add a BGP black hole route, so that this traffic that maybe is flooding your network from is actually stopped at your internet service provider. We are also working on adding bandwidth limitation per user. Right now, we're just doing that for per application, and we will also deliver bandwidth limitation per interface, so that you can limit the whole network, for instance, to 1 gigabit per second. And when you reach that, we we deliver the data all with a better quality than if you just leave it to congest. Okay, so our application is software that runs on hardware. The hardware that we usually use is these off-the-shelf servers from Supermicro. This unit, for instance, costs, well, in US dollars is less than $1,500 US dollars, and it handles up to 10 gigabits per second in 1U. There's other models that we can use up to 50 gigabits per second in 1U. With in this case, it can cost up to $4,000 US dollars. We can also work on with other hardware brands, because the way that we will be working in South Africa is to let you get the hardware. We will specify what hardware is, what server. It's always an off-the-shelf server. We can even use one that you may already have, and then we send you the software. It's easy to install. It's just like installing a Linux distribution. We'll guide you and support you in doing that, and then we send you a license for that. So the deployment is easy, because we work like a 2-port switch, in which you have everything that comes one side will go the other side. Not just one, we can have several links going through us. They will go transparently. You can even have like a aggregated LAC-P bundles going through us. They will go through us transparently. Then we need another connection. So we need a basic minimum of 3, 2 for the data plane at least, and 1 for the management. Okay, here from here is where you configure and see the results. You can have a bypass link, of course, to see if there's our server is taken offline, the traffic will go through. You can implement this with any of the, with LAC-P, with aggregate links, active backup, any kind of scheme that would protect you when a link fails. Would work with us. If you also would like, we now support also 10 SFP plus. We have not SFP plus, sorry, 10G cards that already have an optical bypass that can also be used. It increases somewhat the price, but not so much. So we have over 70 deployments worldwide. We have some customers already. So we have 2 customers already in commercial service in South Africa, and others are now starting to try it out. Here are some references from the US, from different countries, some large networks also. So what our customers usually say, for instance, Interworks, they're from South Africa. They tried this and they really noticed a big improvement in with the streaming video, even when the streaming server was local. And so the number of support calls have dropped, they say, a lot, and so this has helped them a lot. Similar comments we get from other customers. This Genco Wireless is from the US. He had problems with Netflix for some customers. Now those problems stopped. Our improvement was enough so that those problems, the complaints, stopped when they installed us. And also this Plains Internet is a fairly large network in Texas in the US. They got 4 servers. They saw improvements up to 100% in the speed they could measure. So how do we sell this? We sell this with MiRO. MiRO there is our distributor there, and there is a monthly subscription option or a perpetual license, and it depends on how much traffic you is going to go through our system. So if you have 500 megabits per second, the monthly subscription will be around 2,279 rand. Perpetual license would be around a little more than 41,000. Okay, so depending on this 1 gigabit per second, you can also buy a 500 megabits per second license and then upgrade to 1 gigabit per second. The price will always be just the difference of each of these. You can keep adding as you grow in capacity, and we will never stop. If you have a system that can handle 10, physically, but you have a license for 1 and you push 2 gigabits per second, we'll let 1 gigabit per second go through, and the extra 1 gigabit maybe you have at peak time will also go through. It's just that it will not be optimized. We'll only optimize up to the license limit. Okay, and we are offering you so that there's a low risk. Try it, 15-day free trial, no commitment. If you already have a server, we can use that very probably, and so it's a very low risk way in which you can see if this will work for you. And the good numbers that we're showing, if you will get them with your network, and we think you will. So we really encourage you to try it out. So after all this, if any questions. So Christian, maybe. Yes. Hi, Christian.
Yes. Thank you very much for the great presentation. I do have a couple of questions here, if you mind, if I can quickly ask them to you. Does it accelerate encrypted traffic?
Yes, we encrypted traffic over TCP is encrypted with HTTPS, TLS, and so for us it's like any other traffic. We don't see inside it, but we can, if it is TCP, we can accelerate. For instance, most Netflix, most YouTube, in fact, is encrypted nowadays.
Okay. I also have here, is content served from nearby caches accelerated?
Yes, in that case, when there's a nearby cache, for instance, from any of these, YouTube, Netflix, whatever, then sometimes in some of the networks that I've shown you before, those cache servers were sitting in the same data center, just in the same almost in the next rack. So there we accelerate less than if those caches were far away, of course, because there we're not making the data any closer, just about the same. But we are accelerating because of the TCP part. Out of the 3 mechanisms, then the TCP part we still feel. And for instance, in the case of Interworks, they were mentioning that their local servers with TV service, they notice a very significant improvement, and this because we don't use the standard TCP, which is normally slower.
Okay. And then how can I see that it is accelerating my traffic? Does the node show matrix?
Yes. Our system shows metrics. It will give you, for instance, for instance, this is an example of a screen where you will get the acceleration, for instance, for the small size, large size, medium size downloads, and depending on whether they are servers that are close by or medium, not so far, or very remote. So we will give you, you will be able to see how much acceleration your network is getting at all times, and also over time. Okay, the same, for instance, these same numbers over time.
Okay. Work. All right. Does it also work on fiber to the home networks or just on radio access?
It also works on fiber. In fact, we have sometimes the best improvements many times coming in fiber networks, because of course there maybe it is and it is because even if it is fiber network, at the end there's almost always some Wi-Fi. So it's still some kind of wireless network. And in fact, that last Wi-Fi link is sometimes the worst. Okay, so so that's why it will also work with fiber. And in fact, sometimes, of course, if you already have a very large speed with fiber, this will get you to an even higher. Maybe it's less noticeable because you already started with a good speed, but then you can offer better services, like for instance 4K TV resolution.
Okay. And also, what happens if my throughput exceeds the license? Is that traffic blocked?
No. If you have a system, if you have a license for 1 gigabit per second, and there's your system has a capacity for physically for 10 gigs, and you push 2 gig, we will just optimize 1 gig, whatever is extra at random, but we will just not be optimized. We'll just let it go through and optimize up to the license limit.
Okay. How complex is the installation and configuration?
The configuration installation is, we think, quite easy. The software is installed just like a Linux distribution. We get you an ISO file, which you put on a USB stick. You start a server, and it asks you what kind of keyboard, the local time, and not much more. And that's the system then is up. Then you set the IP address for management. You can get in, and if you run a command, it will all be installed. Next thing is to ask us for a license. You send us the hardware ID that our software produces, and that's it. Because once you have the license installed, for instance, the TCP optimization requires really no configuration. You just have to see which are the two interfaces through which the data will come, and the other interface for the management. That's it, because our software learns from the data as it comes, and so if there's a lot of losses, it will learn about that and be more conservative. If there are fewer losses, it will be faster. So not very much configuration at all. We really think, and our customers believe that it is a fairly easy process, and we will be there to support you to do it in any case.
Excellent, thank you. And how does the bandwidth management affect RTT?
The bandwidth management, it can actually reduce the RTT, the round trip time, the latency, because if you limit the biggest volume producers, for instance, if in some home someone is using Netflix, and at the same time someone is trying to play online video game, okay, Netflix will many times just use all the bandwidth available that it can, and in doing so, it will push the latency up because it will be filling up all the buffers in the way. So the other person that's doing the online gaming will not have such a good experience because the latency is very important there to be kept low. However, if Netflix is limited to a reasonable speed, but one in which basically there's no there's good quality, but then the online this latency, this RTT race will not happen, and so the experience in that home for the online person will be very good, and the Netflix person also, because if you've limited it to 4 megabytes per second, you can get full HD. Then they will all be happy.
Okay. And then the last question I've got here is, can the DPI block traffic to a specific domain?
Yes. If you set when we do the bandwidth limitation, if that the rate you set is 0, we will actually be just blocking that traffic. So you can in that way block specific domains.
Excellent. Thank you very much, Jose. We are very excited here at MiRO to have Bequant part of our portfolio.
Okay, we are also very excited to be working with you, and we hope that we can help many networks there in South Africa.
Excellent. All right, thank you. That's all.
Okay, thank you very much to everybody. And if you have any questions, anything, please contact Meru, contact us, and we will together help you to try this out. So thank you very much, and good afternoon to everybody.
Thank you, everybody. Bye-bye.
Bye.